Very good. We're going to talk about normal distribution. Normal distribution. First of all, remember that when we introduce different variables, we start talking about discrete random variables, and also we talked about continuous random variables, discrete and continuous. Okay, for a discrete random variable, we said that, hey, we have a very famous probability distribution that we discussed last time, binomial distribution. Binomial distribution. Well, we have the same thing when it comes to continuous random variable. For a continuous random variable, you have a normal distribution. A normal distribution. Very well. So what are the properties of a normal distribution? When we're talking about a normal distribution, we're talking about a probability distribution for a random variable x. So again, recall that for a binomial distribution, we introduced the probability of that random variable x that represented our y value. Now remember that the graph was like this. Here you had x on the horizontal line, and you had the probability of x on the vertical line. Then, since you could count the variables, you had, for example, 0, and you had a bar on top of 0, you have your histogram. You have 1, the bar associated to 1, then you have 2, x is 2, the probability distribution for random variable x, which is now 2, and so on. Well, many natural phenomena, they are following a continuous random variable, and their probability distribution follows a bell-shaped graph. Okay, it's not that hard to see the bell-shaped graph. If you have your x, random variable x, the probability distribution for continuous random variable x following a normal distribution is this function, exponential function, y equals to 1 divided by sigma times square root of 2 pi times e to the power negative x minus mu squared divided by 2 sigma squared. This is your y value. The probability distribution for your y value is this function here. You get an exponential function, and the graph is like this. Okay, a bell-shaped graph. This is the graph of this function. This is the graph of y. Luckily for us, we don't have to memorize or use this formula at all. Everything is built into our calculator. This function is inside our calculator. So don't worry about memorizing this function or using this function to calculate the probability for random variable x. The note video. So a normal distribution is a continuous probability distribution for a random variable x. Well, the graph of a normal distribution is called the normal curve. A normal distribution has the following properties. Okay. So for a normal distribution, the mean, median, and the mode, they are all equal to each other. So mean, median, and mode are all the same. Number two, the normal curve is bell-shaped, and it is symmetric about the mean. Okay, so what's the meaning of that? It means that if I consider this vertical line to be my representative of the mean, mean is on the horizontal line. Everybody, note that mean is on the horizontal line. This vertical line just shows that mean is represented down in the center. If I just fold this graph with respect to this vertical line, dashed line, this area on the right and this area on the left are mirror image of each other. So that's why we say that a normal curve is bell-shaped and it is symmetric about the mean. Well, the total area below the curve is 1 or 100%. So if you're calculating this area, the total area is 1 or 100%. The normal curve approaches but never touches the x-axis. So as you can see, there are some gaps. There are some gaps to the left and to the right of these tails. They are not touching x-axis. They're just approaching. Well, for those of you who are in calculus, we learned about inflection points, but if you are not in calculus classes or you don't know what inflection points are, that's absolutely fine. Inflection points are the points where the graph changes its curve. So the graph opens up, then it starts opening down. This point is called inflection point. Again, on the right-hand side, the graph opens down, then it starts opening up, and you have another inflection point. The inflection points on the graph are associated to mu minus sigma and mu plus sigma. Very well. So you learned that a discrete probability distribution can be graphed with a histogram. Yeah, we saw that before. Here you have a histogram for a discrete probability distribution. For one of them was, the famous one was binomial distribution. Now, for a continuous random variable, the continuous probability distribution can be graphed using this function, the exponential function y equals to 1 divided by sigma times square root of 2 pi e to the power negative x minus mu to the second divided by 2 sigma squared. Remember that e for Napier number is approximately 2.718 and pi by approximation we just say it's 3.14. You can use a probability density function or PDF. A probability density function has two requirements. First of all, when you have a probability density function or PDF, the total area below the graph must be 100% or 1. Okay, this guy is PDF, probability density function. So the area below the graph is 100% or 1. 2, the function can never be negative. It means that the y value of the function doesn't go below x-axis. A normal curve with mean mu and standard deviation sigma can be graphed using a normal probability density function that is defined here. Very well. So When you're talking about bell-shaped graph, they have different scenarios, different cases. So suppose you have a bell-shaped graph on the horizontal line, X, and the graph behaves like this. This is your bell-shaped graph. Okay, then the mean is given to you as, for example, okay. And you have another bell-shaped graph here. Okay, this bell-shaped graph behaves like this. Let me use a different color so you can differentiate between them. And the mean of this line is just 5. Okay. So my question is, which graph has more variability? Which one is more varied? What's the meaning of that? Which one has larger standard deviation? So these two questions are equivalent to each other. Which one has more variability? It means that which one is more wider than the other? Which one is more wider? These questions are all equivalent to each other, guys. So if you read the question, which graph has more variability? It means that which one has a larger standard deviation, or which one is more wider? Okay. Which one is more wider? Which one? So as you can see, the purple graph has more variability. Why is that? Because it's wider. Even though I don't have the exact standard deviation, by looking at these two graphs, I can say that, hey, my purple graph has more variability. It's more wider, so I have more variability in the data. Variability, or another word for it, standard deviation. It is more varied. The wider the graph, more varied the data. For example, give us an example. Think about housing prices in San Jose. Housing prices in San Jose. So just quickly Google housing prices in San Jose for me. Are they varied, or they are close to each other? What is the minimum value that you see? What is the maximum value you see? Are they close to each other, or are they far away from each other? So as you saw, you had variability from 600,000 to 15 million. It means that the distance between the data is a lot. So we have more variability. More variability in the data. Now we are collecting the monthly rent that students in a university are paying. And our goal is to do a little bit of computation. Example. The monthly rent that San Jose State University students are paying each month is given. First of all, find the mean, then find the standard deviation. Then we're going to answer this question. What is the probability that a random student pays more than $1,000 each month? So this is the very first question that you're going to answer. So take your time, compute the mean and standard deviation of the data for me. Then I'm going to show you how to answer a question like this. So the mean is 1,685. So let's just keep it as dollars. They pay around $1,685 with standard deviation as 624, approximately $624. Okay, this is our standard deviation. Very well. So assume the data is normal. How do we calculate the probability that you randomly select a student and that student pays more than 1,000? What are you going to do? You're going to use your calculator. To use your calculator, you're going to click on, so let me write down the calculator, stops here for you. Calculator. You're going to go to second. You're going to go to bars. So, calculator, second, bars, and you're going to find normal CDF, cumulative density function. Normal CDF. This is the same function that we just introduced. Then click on that. Here, you're going to enter a number for lower limit, a number for upper limit. Then you're going to enter mean and the standard deviation. Okay, so let us get back to the question. We want to know what's the probability that a random student pays more than $1,000. So $1,000, more than $1,000. It means that 1,000 or 1,100, 1,200, 1,300, and so on. So your lower limit is going to be 1,000. Lower limit is 1,000. So enter that. What is your upper limit? Well, you might say that, hey, I know what is the maximum value in my collection. So if you have the maximum value in your collection, enter that. If not, for the upper limit, use a large number, like $5,000, $6,000. Any number works here. So let us just enter $5,000. You might say, hey, why not $8,000? Use $8,000. Mean. What is the mean? We calculated the mean, which is 1685. Okay, 1685. And what about the standard deviation? The standard deviation is 624. 624 and paste. Enter one more time, and you see this decimal number here. The probability is 86.38%. The area below the graph is 86.38%, which is exactly the probability. what is the probability that a random student pays more than $1,000 each month? The probability is the same as the area, which is 86.38%. Okay, now what if I ask you to find the probability that a random student pays less than $1,000? Okay, now I'm going to change this to a less than. So what if we change this to less than 1,000 a month? What is your lower limit? What is your upper limit? Very good. So now suppose we want to know what is the probability that we randomly select a student and that student pays less than 1,000 each month. So go back to your calculator. I know many of you mentioned 1 minus, the previous probability. Yes, cool, that's absolutely correct. But for the sake of, practicing, let's use our calculator. So here, second, bars, then go to normal CDF, and then the lower limit in this case, because we are saying that less than 1,000. It means that, for example, $900, $800, $500. So use a very small number. Remember that when we talked about the graph of a normal distribution, the graph never touches x-axis. It just approaches x-axis on the left and on the right. So you can use a very small number and a very large number. So let's go back to our calculator. So I'm going to, for example, use 0 for the lower limit, and the upper limit is $1,000. Okay, very good. So 0 and $1,000 mean the same, standard deviation the same. Just do the paste and do the calculation. Well, as you can see, we have 13.27%. So the area below the graph, below the graph, or the probability, or the same thing, is 13.27%. So the probability that you randomly select a person and that person pays less than 1,000 per month is very small. It's just 13.27%. So now what if we change this? Now what if we want to know what's the probability that a random student pays in between? Okay, pays in between. Let's see. What if you randomly select a student and that student pays between $1,000 to $1,000 and $200? How do we find the probability? What are the steps that we're going to take? So in between, it means that the lower limit is 1,000 and the upper limit is 1,200. So here now, you can find these 1,000 and 1,200. Mean stays the same, $1,685, and the standard deviation $624. And we go to second, bars, normal CDF, and the lower limit is $1,000, upper limit 1,200, meaning the same, standard deviation the same. You do the calculation, you get 82.35%. So the area below the curve, or probability that that person pays between 1,000 or 1,200 is 0.0, okay, 82. So it's 8.24%, all right, 8.24%. I read it wrong, it's 8.24%. Very good.